So today we're going to start talking about something that's going to be super important, soup import for Comp Sci 2, and something that you're going to be doing pretty much from here on out. And it's called non-void methods. So we're going to first take a little bit of notes on your own, so you need your own blank sheet of paper. And then after that, I'm going to get into this method machine packet. So you should have that nearby also. So if you don't have that or a piece of paper, get those out now. But we'll start with just the general notes about non-void methods. Okay, so we're going to title this just Notes, Non-Void Methods. Okay, so up until now you've written a bunch of methods, but every method that you've written has had a return type of void. Up until now, the return type has always been void. And I've had you write public void since pretty much day one of Comp Sci, and I never really told you why. Just one of those things that you just did it. Here, hopefully, we'll start to explain why that is. So first off, a return type, return means it sends an answer back to where method was called. So whenever you see return, we're going to send answer back to where method was called. I hope by now you know what it means to call a method. You know, like when in your run method you'll write right heading, you're calling the method right heading. You're saying do right heading. So if return sends an answer back to that spot, void means nothing. So when you do public void, everything we've been doing so far, that returns nothing. But now we're going to have non-void methods. We're going to start returning actual values. Okay, so let's talk a little bit about how we're going to write these methods. So some properties of these methods. First off, the method definition. By method definition, I mean where you say what the code the method does. So public void right heading, and then system.out.print, whatever it does. Here's what it's going to look like in general. You're still going to write the word public. Eventually, if you get to AP Comp Sci, you might have private written, or you might even see that a little bit later this year. But for now, always still write public. And then what I write in red here is going to be different depending on what method you write. There'll be some sort of return type next. We'll talk about what those can be in a second. So you're not actually going to write the word return type when you do this. You're going to write whatever type of variable is being returned. If no variable is being returned, we write void, just like always. After that comes the method name, like you're used to. Write heading or get info or read file or whatever. And then in the parentheses, we're going to put parameters. Again, different from Comp Sci 1, but what you did in the secretary's program. So you'll write the type of the parameter, so like int or double, and the name of the parameter, the name of the variable. So type parameter 1, and you know you can send over as many variables as you want. So you'll write type parameter 2, if there is 2 parameters, and that can go on for as many parameters as you want. And again, when I say type, I mean the type of variable that parameter is. If it's an int, you're going to write int. If it's a double, you're going to write double. If it's a char, you're going to write char, etc. All right, so that's the method definition. Inside goes whatever code the method does, like always, and then we end the bracket. Okay, so I said I'd get back to talking about this return types. Here are what you can put in that spot. So return types other than void. You can make ints, like public int. You can make a double. You could do public booleans. You could do public chars. You could do public strings. What I'm getting at is you can do public anything, any type of variable. So whatever you want this method to calculate or give back to where the method was originally called is the type that you'd write in here. Okay, so let's get to a little bit more concrete example so you can see what I'm saying if you're confused at all. So an example that you've all used before without knowing it is the square root method. So you know that when you've done math.sqrt way back in comp sci 1, what type of variable gets returned? Anytime you did math.square root, what type of variable was it? Right, it was a double. So square root returns a double. That's why they always had point zeros on the end if they were nice. This method is written or defined in the math class. That's why it's always math dot. We're accessing the math class when we do that. And you know, like, and if a program, if I had a variable called like double x, and then you did x equals math dot square root, sqrt, and if I sent it 25, what would x equal after that code was run? It'd be 5.0. So again, square root is the name of the method. 25 is a parameter I'm sending it. It's doing something with 25. It's somehow making that into its square root. And it's sending back an answer of 5. But since it's sending back a double, it's really sending back 5.0. So it would be sending it back to this spot where the method's called, and that would get set equal to x. Somewhere in the math class, there's a method that looks like this. It would say public, and instead of public void, it would say public double. And then the name of the method, which is sqrt. And then it's accepting some parameter. Mine was an integer in my example, but you could send it a decimal. So there's probably a parameter called double num. Okay, and then there's some code written in here. I'm not going to go through what that is right now, but some way to turn num into its square root equivalent, and then it gets the answer back. Now the real thing I wanted to focus on here was the method definition. So like I said up here, you have public return type. Here the return type is double. Because it's going to give an answer back that's a double variable. The method name is sqrt. Method name. And when I wrote type parameter 1, type parameter 2, in this case there's only one parameter because I only send it one value. And I'm calling the parameter num, the name of the variable, and the type that I'm allowing it to send is a double. So the stuff in the parenthesis, just like from secretaries that you're getting used to, is the parameter list. Okay, Now, how to actually get it to return the value, we'll talk about in a second. But that's basically what's happening. Okay, last part for your own notes here. So this is number 4, I guess, just some general rules for using these non-void methods. Methods with return types other than void must do the following. First, they must return a value whose type matches the return type in the method definition. Return a value whose type matches the return type in the method definition. So if square roots is called a public double, it better return a double variable. It can't return a character, it can't return a string. Technically it could return an int because an int could be made into a double, but in general you always want to make sure the thing you're returning has the same type as what you're saying should be returned. The next thing a method with return type other than void must do, it must return a value using the keyword return. Okay, so that's how you get a value back. And you'll see when I write some examples in a second. But at the end, usually the last thing in my code, it'll say return something. The word return is one of those words in Eclipse that turns purple, and it signifies that whatever comes after it is the value that this method is going to send back to wherever the method was called. But it must do that. If it's not a public void, you have to have a return. Okay, 2 more things. It must return only one value through the method itself. So you can only, that's kind of a limitation to these, is if you want to return multiple things, you can't do that. You can only return one variable at the end. Now there are ways around it, and that's why I wrote through the method itself. We'll talk about what those ways around it are later, but for now, just know that you can only return one variable, no matter how many you put in as parameters. And lastly, it must return a value in all cases. And we'll talk about that a little bit more with some examples also, but this mainly comes up if I have a switch statement or some if-elses. I can't have a scenario where it doesn't return a variable. No matter what, it has to return a value if it's not a void method. Okay, so that's your quick basic intro here. Now we're going to switch over to the next packet, which is the method machine packet. And this is going to take us through a lot of different examples, and we're going to do this over multiple videos, over multiple days. Today I'm just hoping to get through the first 2 pages. Okay, so method machine. This little graphic sometimes is more confusing than it's worth, but what I'm trying to show by these things up here, X, A, B, and C, those are input values. And in computer science terms, you should be thinking of those as parameters. Okay, and I have 4 listed here, but I can have as many as I want. So parameters have no limit. You can send in as many different values as you think the method needs. And the method does something with those parameters. So this stuff in the middle is like the code. So I take these 4 values, I do something with them, but no matter how many values go in, only one value can go out. So the output is this y here. And in terms of computer science, those are your returned value, or is your returned value. And that's what I was trying to get at with one of those bullets in the last line I just wrote. You can put in as many parameters as you want, but no matter what, there's only one value that can get returned. Okay, now when you think of this, kind of think of them like functions. So over here, I'm going to just say, remember functions from math. And no matter what class you're in, you should have talked about functions before. You deal with them pretty much all the time. Functions, I've got like f of a is equal to 2a plus 3. The first couple examples of methods that we write in a second here are going to be kind of just like these functions. So my input, if I asked for, let's say, f of 4. So think of this in terms of comp sci. F's the name of the method. A is the parameter. So in this case, I'm sending it 4. The method has code that does something with 4. In this case, it takes 2 times 4 plus 3, which is 8 plus 3 is 11. It calculates 11, and it sends back that value. That's its return. So if I wanted to write this, let's say, in a driver somewhere, I could say int num equals f of 4. And the method returns the value back. So if I go to the method f and send it 4, it's going to give me back 11. So that means that later on in the program, 11 is sent back to where it's called, which is right here. So this value equals 11. Then the method does, or the program does something with it. So if 11 is set back, what does it do to 11? Well, it sets it equal to num. So from here on out, the value of num is 11. But I'm going to say that a lot too. You have to do something with what it's returned. I couldn't just write f of 4. That'd be stupid. Because then 11 would get sent back, and then it's just floating in space here. Nothing's doing anything to it. You need to do something with what's returned, whether that's putting this inside a system.out.print so that it prints out 11, whether it sets it equal to a variable, so a variable now is 11. You got to do something with it. Okay, down at the bottom, you've got some predefined methods that you've used throughout the year. Mostly all these are in the math class. Math.abs. ABS stands for absolute value. I think some of you might have used that at some point. The returned result is it takes the parameter x and gives you back the absolute value of x. You've used math.pow a ton. There's 2 parameters. This was the exponent. This was the base. This was the exponent that the base was raised to. So the result is we're going to do x to the y power. And that's what's going to get returned back. We've talked about math.square root. We know the result of sending it x is that it sends back whatever the square root of x is. And you've used math.round a bunch too. And we send it some double variable x. And what math.round does is it returns x rounded to the nearest integer. And all of these are non-void methods. These are the values that get returned. Okay, so let's flip over to the back of this page and we will do examples 1 through 3, and then that'll be the end of this first video. Okay, so now would be a good time for questions. If you're watching this in class right now and you've got any questions, maybe pause the video real quick, raise your hand, bring me over so I can explain something before we start doing these examples. Or if you're watching it at home, or if I'm not available, maybe make some notes where you want to ask me questions. And when you're ready to go on, here's our first examples. Okay, so I said we were going to start with mathy type examples, a linear function. F of x equals y equals 2x minus 3. So here's some examples of some input x values. Those are parameters, remember? And you could do more than just 0, 1, or 2, but this is just some examples. And here's some examples of some output, which are my return values. When I input a parameter of 0, I'm going to return a value of negative 3. When I input a parameter of 1, I'm going to return a value of negative 1, etc. And I'm actually going to show you two ways to do this. It says ways. First is kind of the way we've been talking about so far. Always start with the word public. And, I mean, technically you could put any decimal in here also. Given the examples over here, they're all integers. So let's just say we're going to put in integers. If I put in an integer, I'm going to get out an integer. So the type is going to be public int. The name of the function is f. So the name of the method for me is going to be f. And then we have to send it a parameter. And I said for the sake of argument here, let's just send it integer parameters. So I'm going to send it, I have to list the type always, remember, int x. When you're defining a method, remember you have to define the type of parameter. It's like you're making a variable in here. Okay, so the first way to do it is a little clunky, but it makes sense, I think. I'm going to make a temp variable. I call it int temp. And then what do I want this method to do with the variable I give it? Well, I want it to multiply the variable by 2 and subtract 3. So if we set temp equals to 2 times the variable x that I'm sending it plus 3, now temp is the output value. That's the value I want to return, so we have to write the word return, and the value I want to return is whatever temp is. So I can say return temp. That's one way to do it. Now you can actually do it a little bit more streamlined. So the other option, you still have to do the method definition the exact same way. So it's going to say public int f and we're still going to get the parameter of x. So you're going to see int x. But you can actually do math right in the return statement. So you can do this without a temp variable at all and just do this in one line of code and write return 2 times x plus 3. And that blue code does exactly the same as that black code. So if that makes sense to you, this is a much nicer way to do it. If not, and you'd rather use a temp variable, go for it. Now, throughout when I do this, I'm going to talk a little bit about method calls, which basically means, you know, in your actual program where you use this method. Because you always have to do something with what's returned. And I said I was going to mention that a lot. Hopefully you're going to get the idea here. So in maybe my driver or something, I'd have a variable called int num. Assuming this function's written in the same same class where we're calling it, so I don't have to do like C1 dot or S1 dot to access it. If I just wrote num equals f of 8, then I'm doing something with what's being returned. I'm calling the method f, I'm sending it 8. F of 8 would be 16 minus 3, so 13. So it's sending back 13 to this spot right here. Let me circle it in red. That's where 13 would get returned to. And what does the program do with 13? it sets it equal to num. Here's another way you could use the method. Rather than doing that, you could just, rather than saying num equals f of 8, you could say system.out.print f of 8. So again, it's calling the method f, it's sending it the parameter 8. That method does this calculation with it. It figures out that the answer's 13. Since it says return temp or return the math, it returns the value of 13 to where it's called. So after this calculates 13, it returns it right to that spot. Now this is 13, and the method has to do something with it, or the program does something with it. 13 is not just floating in space, it's saying system.out.print 13. So it's printing out the value 13. What you would not ever do is just write f of 8. And Eclipse isn't going to give you a problem with that, but that's going to send 13 back to this spot, and then it's just going to it's going to sit there and have nothing happen to it. It's not going to be equal to a variable, so it's not going to be saved. It's not going to be printed out, so you're not going to see any result. So you want to do something with the what's returned, whether that's set it equal to a variable, put it in a system.out.print, or something else. Okay, so if that concept is confusing to you, call me over and ask, but I'm going to keep giving you examples of what you could do with return values. All right, number 4, not much different. I've got y equals x squared minus 4. This is a quadratic function. So you can see I'm still inputting all int values. I'm returning all int values. So for the sake of argument, let's stick with public int again. I'm going to do this 2 ways again, so give yourself room. So since I'm putting in an int, I'm going to get out an int, so that's why it's a public int. What's the name of this method going to be, do you think? Well, since the name of the function is h, let's call it h. How many parameters, if any, are there going to be? Just one, because we're only giving it one variable. So int x again. And let's do the temp way. And I'd want to set temp equal to this math. Now this math is squaring it minus 4. So how could I square x? Well, I can think you would make one of 2 responses. You would have said, well, x squared is just x times x, so I could just do that. Or I could use math.pow. We'll do one both ways. For this one, let's just do x times x. So x times x minus 4 is going to do x squared minus 4. What's the last line have to be in here? Good. Return temp. Because you have to return. You have to give it back a value because it's not a public void. So if this was a public void, that's when I don't need to see the word return. Okay, the other way. Method definition we said would be the same. So still public int h, sending it a parameter of x. And rather than making a temp variable, let's just return. And we could return exactly the math we did last time, x times x minus 4. But assuming you thought to use math.pow, you could also return math.pow. Remember how to use math.pow. You've got to send it the base, and x is the base. So x, comma, the power, it's x squared, so comma 2. And then make sure you still do the math equation. So it's x squared, that's what math.pow did, but then we still have minus 4. Okay, now there actually is an error with this, and Eclipse would give us an error if I wrote it this way. Does anyone see why? It's a subtle thing. What is math.pow? What type of variable does that return? Math.pow, any math dot returns a double. So I'm going to return a double, but I said I'm returning an int. And a double cannot be made into an int. We can go the other way. An int can be a double, but not vice versa. So if you're going to use math.pow, the only way you can make this work, well, there's a couple ways, but if I make this a public double, now I can use math.pow. Or I could have cast this as an int, either way. But be careful of that. If you're returning a double, you can't have a public int. Okay? Any questions? Call me over if there are. All right, last one for today. Ooh, we got a piecewise function now. So we've got 3x minus 1, 4, and 2x plus 2 in these different possibilities. So let's start with, again, let's just assume we're giving it, in this case, let's say, so these are all x's greater than 5. Technically, I could put in decimals, so just for the sake of argument, let's do public double this time. So public double, and the name of this function is g. And let's say I can send it a decimal as well. So the parameter will be a double also. We'll call this double x. And let's do it with a temp variable. So double temp. So since this is a piecewise function, I've got different options. So depending on what x is, depends on what math we do. So if I say if x is greater than 5, then we would set temp equal to 3 times x minus 1. So we got 3 options. We should use else if. So else if, what can I say here? Well, I've already taken care of x being greater than 5, so I don't really have to worry about being less than 5, because if I'm here, I definitely am. But if I'm greater than or equal to 2, again, less than 5 is implied, because otherwise it would have gotten hit by this if. Temp just equals 4. And then finally, for all other cases, else temp equals 2 times x plus 2. Am I done? No. What do I have to put at the end? Return temp. Make sure you're returning something. Now I'm done. All right, now what do you think? Could we have done this last example without a temp variable? Sure. And if you want to write this in, you can. I'm just going to kind of change it really quick here. You can write it without a temp, so I could ditch that totally. Instead of writing temp equals 3 times x minus 1, I could just write return 3 times x minus 1. And instead of saying temp equals 4, I could just say return 4. And instead of saying temp equals 2x plus 2, I could just say return 2x plus 2. And then I wouldn't need this return temp thing at the bottom here either. So you can do that. This is a little dangerous because this is what I was saying on your own notes earlier. You have to make sure you return something in all cases. So I need to make sure that no matter what, there's a return. Along with that, if you wrote if x is greater than 5, else if x is greater than or equal to 2, and if you said else if x is less than 2 here, you're smart enough to know that all cases are accounted for. But if you don't have an else case, the computer would be mad at you because it would be worried, what if I just have if, else if there's no else default case, if there's no return for every single case, I'm going to be worried. So you can do return right in if else's, but again, just make sure you're accounting for all cases and make sure you're returning in all cases. Okay, so that's the end of where I wanted to get through today. We're going to continue on this packet in the next video, so save it If you got any questions, please make sure you ask me before we go on to the next stuff, because the next stuff is going to get a little bit trickier than this. Otherwise, thanks for watching.